Welcome everybody. Welcome to this webinar about the presentation of the master degree in nanotechnologies for ICT. Okay, so you have the chat where you can make your question. So welcome to this webinar about the presentation of the master degree in nanotechnologies for ICT. Yes, thanks. My name is Carlo Ricciardi. I'm a professor of condensed matter physics, and I'm the referent coordinator of this master degree in nanotechnologies for ICT. So this half an hour will work like this. I will make 15 minutes, 20 minutes presentation. If you have a question during the presentation, you can make anytime, just write it on the chat. And then at the end, I will also take other questions. So, first of all, we have to define what is the topic of this master, that is nanotechnologies. So, instead of seeing in a sort of simplistic way that nanotechnology are just smaller microtechnologies, nanotechnologies are I prefer this definition in which nanotechnologies deals with design and exploitation of materials, devices, and systems to the control of matter and its interaction at the nanometer scale. That's because the nanometer scale, as you can see in this nice picture, it is the molecular scale. So, as you know, the matter, the nature is not continuum. When you go shrinking the dimensions smaller and smaller, sooner or later you go to fundamental units that are molecules or atoms. And when you go to that scale, that is let's say the heart of everything, because if you are able to understand and to dominate, to rule, to tune the interaction of that scale, you can basically play like nature and form new material with new functionality that are not present, let's say, in what nature has made. So what you can see in this picture it is the same scale that you see in the middle, and then in the upper part you see what is let's say nature made, and in the bottom part you see what is human made. So lab on a chip system, micro mechanical system, or nanoscale system. As you can see, that is a really hot topic of today. A virus is by definition a nanoscale system. It is basically a nanoparticle, and the droplet that you have heard of about, that is the carrier of the virus in the air, that are a nanoscale system. So again, dominating nanoscale means dominating the let's say the scale at which nature is making normally is on job. So just an example that I like a lot, that's a topic I'm working on, but maybe it is, I think it's a very clear example. This is an example of an artificial synapse. So on the left side, you can see a biologic synapse. And if you go back to the high school, you have done it for sure. You remember that this is called synaptic cleft, where there is this very tiny part in between the pre-synaptic neuron and the post-synaptic neuron. That's again nanometrically. That's 20 nanometer of thickness. And that's a place in which ions are moving forward and backward. So we fabricate the same, let's say, functionality with an artificial synapses that is made of a nanowire in which silver clusters are moving forward and backward. So no details about this, but the concept, it is really a nano idea. So emulating nature, learning from nature, and trying to build from a human let's say from a man-made perspective, trying to build a device that is not normally present. So this synapses, biological synapses are, for example, they are not binary, obviously, they are not digital, they are completely analogical. So you need a device that is not a normal transistor device or whatever. So that's the idea. So instead of trying to emulate the whole behavior like normal artificial intelligence, it is like software, computer science based. We are trying to emulate what is happening at nanoscale. That's the, and from a more hardware point of view. Well, yes, then if you have a curiosity about this, that's a topic of my research, so I can reply for sure. But that's just an example, right? So again, on the introduction, two adjectives for nanotechnologies that are typically used: pervasiveness and multidisciplinarity. So nanotechnologies are pervasive. Maybe you don't know, but they are everywhere. So as I said, very to say up-to-date example, virus are nano technological system, and they are nanoscale system. But you have nanoparticles, for example, in a lot of cosmetics. You have nanoparticles in food. You have and the heart of ICT, that is the transistor you have in your phone, in your tablet, in your PC. You're looking to this presentation. They all have at least one feature that is on the nanometric scale. So they are already there, not just in computing or electronics, but also for other applications like energy, environment, biomedicine, etc. They are a promise for improving the quality of life, and that's a really important thing, especially because since they are really small and they can, like the example of before, they can go to very low power consumption. They have also a lower environmental fingerprint. That's a very important thing. They could be things that are in your own hand. The other thing that is important, it is the multidisciplinarity. Sorry, there is an error in the slide. So nanotechnology, nanoscience is not, how to say, an old discipline like physics or electronics, chemistry, or things like that, but it is emerging of more than one of this. So it is intrinsically a multidisciplinary. So if you are willing to go in that direction, you should face not just physics or not just electronic engineering, but also material science and something of chemistry, something of biology, and etc. It's a really different field. The last flag typical to nano is K-enabling technology. So KET, and that is recognized also by European Commission that already some years ago point out a list of the 6 K-enabling technology of the future to solve societal challenges. And the first one, as you can see here, is nanotechnology. So that is a proof of the large interest from the European Commission, for example, for this kind of technology, and it is for this kind of curriculum from you as a student. Okay. Sure. Okay. Sorry, I think I went too fast. Okay, that's here. Yeah, I did already a presentation yesterday in Italian. I will repeat in English. Some of the possibilities are not completely available, but this could be still a good description also for the future, or even you can change once you have made your choice. What I mean is, we have basically in our we call educational path. So these 2 years of master degree, we have 2 main tracks. So depending on your after your bachelor degrees, we give 1 master degree in nanotechnology for ICT. We have 2 tracks that we call national and international track. That is not a very good definition that I would like to to change, because all the courses that we have are international. So nanotech for ICT, it is international, it is with international students, it is all in English. So we call national track because at least the first year it is made entirely in Torino normally. So that's why we call it like this. But in both cases, while the second case, it is already predefined track in between Torino, first semester, Grenoble, second semester, EPFL in Lausanne, the third semester. So in the first case, there is a national master degree in nanotech engineering. And in the second case, there is a joint diploma between Polito, INPG, and EPFL. The second case is limited number. So 20 students per year per partner. So 20 enrolled in Polito, 20 enrolled in Grenoble, 20 enrolled in EPFL. Yeah, I will say in a minute which is the difference between the two in terms of subject. Okay. What I want to underline is one thing is, so I kept in Italian because that's an Italian definition, but the classe di laurea, that is the, let's say, the kind of degree, it is the degree in electrical engineer. So at the end of the course, even if I'm a physicist, and you will see there are a lot of there is a lot of physics inside this course, but it is still an engineer, electrical engineer curriculum, right? In which it is maximized all the credits, all the hours that can be devoted to physics. Okay, so yeah, to reply the question of a student, these two main tracks are slightly different from the focus. So the national track, the one completely in Polito, it is more focused on the physics of the material. So nanophysics, advanced material and process for micro and nanotechnology. So the idea is, like the example of before, that we focus more on some nanoscale aspect that can be exploited to design a new device. On the slightly difference, the international tracks is more focused on design and realization of the micro nano system. So the difference is not that large from the knowledge point of view. It is larger from the, let's say, from the kind of lecture point of view. That is, in the international one, you will go to Grenoble, where there is a clean room, that is where you fabricate these devices, that is devoted to students. That is quite unusual, so to have an entire clean room devoted to students' project. And slightly the same will be in EPFL, where you can do semester project directly in the clean room. That is not what you can do in Polito. So let's say if you want the so in Polito, we concentrate maybe more on the physics, on the characterization of the material that is inside the device, while in the international one, you go more on the design and then the realization of the entire device, entire system. That's the main difference. But let me say, we're talking about 2 years program. First semester is basically the same. You are the same students because the first semester is in Torino. The last semester of the second year, it is entirely for thesis. So at the end, there is just 1 year of different, in which there are some topics that obviously are mandatory. And so at the end, there's not that large difference. So I catch the question, even though the international track is located in France, is the course main language English? Sure, I'm Italian. No, it is all English, always English, completely in English. Yeah, there is no other language. Could you tell us how much is the average that a student should have to be chosen for the international path? Okay, I will go maybe to the end. It practically depends on how many students are applying, and then there is a part for the average and a part for the colloquium. So I would say, let's say at least 26, and that would be difficult to not enter if you are more than 28, right? So that is more or less the idea. I will tell you at the end, right? But keep in mind that the semester, the inscription, the applying for the international one, it is expiring on this Sunday for who has an Italian degree. For the international, it is already expired, I think on the 5th of May. If you have a question about the Grenoble semester, I would be glad. Okay. Hi, Liliana. Good that you are here. Good. Thanks. Okay. So let me go forward. Yes, I was saying. Yeah. So if you want to add a comment, that are more than welcome. So that is a difference in the educational path. So I will not go in details, but you can see on the website that is, and you can take your time to look at the program of the single courses. But I just did this. I put this agenda that you see on the upper corner, right corner. So in blue, they are the course that are more, let's say, the subject, and the teacher is more related to physics, and in green, they are more related to electronics. And in black, they are the elective courses or related to others. So you can see that there is a balancing between physics and electronics, and the same it is more or less for the international one. Maybe I would say in the first semester, in the first semester of the second year, there is a more how to say focus on micro and nanoelectronics in EPFL respect to the first semester in Polito. I think that's the main difference. You can have a look to this educational path on the website that you can find here. So you can follow the link and see all the details, or also ask other colleagues like Leah. Remember that you have an entire semester for the thesis, for the master thesis. That is a very good thing. So, about the bachelor degrees, if you're coming from inside Polito, there are no specific requests. If you come from the same school, collegio, so electronic engineer, physics engineer, computer engineer, electrical and communication engineer. For adult bachelor that are typical, like biomedical engineer, materials engineer, or mathematical engineer, we normally ask you to add an additive course of electronics. It's not really additive. It is just substitute instead of this black course that you see here. So instead of the elective course in the first semester, we force you to take a course of fundamentals in electronics, right? If you're coming from out of Polito, then it depends really on your background. I give a look to your background, and then I decide if for example, if you're coming from physics, pure physics, most of the time you are weak in electronics, and so we need to add you this to force you to put as mandatory this course of fundamentals of electronics. But it really depends. For example, here in Torino, in physics, I know there are some elective courses in electronics, so some students in the past did not need to go for an additive course in electronics. So, okay, main strength of this course, I think it is internationalization. So this course, whatever it is, the national or international path, it is completely in English. What degree of quantum physics understanding that this course offer? Well, that is a good point. Let's say to go without any, let's say, gap in knowledge, you should have already a basis of quantum mechanics. Yeah, I forgot to say the spring that is important. So the first course that is really foundational for this kind of course, it is called solid state physics. And it is a course that is already starting from an idea that you have already an idea of bands in solids, or the so-called block theorem, what is happening in electrons that are in a solid. So that means to understand the band diagram, you need to know something about quantum mechanics. So that is typical for our students in physics engineer, for example. If you don't have it, what we do is we divided the class in two groups. One group that is already, let's say, experienced in basics of solid state physics, and for that group you will start from an infinite crystal, and then you will start taking away the single dimension and look at the so-called quantum confinement. So most of the properties at nanoscale, they are related to quantum physics. So it's something that you need to know, and you normally you work with it day by day. So the degrees of understanding at the end of the course, it should be really, complete, I would say. If you don't have it when you start the course, the master degree, then we will help you in filling this gap. So as I was saying, we divided the class in two, and then who has no knowledge about quantum mechanics will follow, let's say, compressed course of quantum mechanics and fundamentals of solid-state physics, right? So in that way, they will be able to re-emerge at the end of the course. Then obviously, while you are studying something, the other students are moving forward. So if you wanna close the gap, you need to study also on your own. But that's normal. I mean, that's intrinsic in the idea of bachelor and master degree. So it's not one unique path, but they are two separate things. So if you take a student that has done a bachelor in physics and another in electrical engineer, obviously the first will have a better knowledge of physics and the second of electronics. This course is a marriage of the two, so there will be students always good in one thing, better in one thing respect to another. So all the students should try to fill this gap. That's in the idea of all the master degree. Okay. So I was saying about the internalization. So you need to be fluent in English. You need a B2 certificate. That this year you have 1 year more to get it, but it's out of the certificate. It's really important that you are fluent in English, and this is really important. I would say really needed for the today industry, high-tech industry. English is the topic here, is the medium of all the discussion at the international level. So in technology and in science. So I think this is a strength. So I strongly suggest you to go for a master degree in English. Then we, apart from the international program that I told you, we also have some double degree at Erasmus program, obviously. Especially we care a lot about double degree. So we also have a double degree with the same institution, Grenoble. And we have other two double degrees that are, one is called NanoQuad, quantum nano devices. That is pretty nice. So it is the most, let's say, physical one, in which we work with Paris, and in which the students do the first year in Torino and the second year in Paris Diderot, and they specialize in quantum devices, so devices that are using quantum or measuring quantum phenomena like quantum computing or other quantum phenomena. There is also a new one that is called Photonics for Security, Reliability and Safety. This is a joint master degree from Erasmus Mundus. This is the apply is really soon, so it's already closed for this year. So you can have a look maybe if you're interested for next year. This is about photonics. So just one semester into it. Okay, so I am using some data that I took from Grenoble. So in the strength about internalization, I think there is also a very good point that is about the thesis, the master thesis that is done abroad in the really top level research lab. Like you can see here some example, IBM Center in Almaden, MIT or Jet Propulsion Lab of NASA it is in Los Angeles, in Pasadena. So what you see in this graph are the different nanotech students, N1, N2, and 14. We are at N16 this year, and 17 will be next year. Yeah, N17, yes. So this is not completely up to date, but you can see that most of the students are doing the thesis all around the world. For example, in Italy, that is the yellow bar column you see. There are just few. Just to say that this is really typical of this master to have students that are in US or all around the world doing their master thesis. And this is also thanks to another strength that is the community. So what we are proposing here is not a master degree in nanomaterial or something like There are others in Europe or also in Italy about nanomaterials. They are commonly in under, let's say, the environment of materials science or materials engineer. While here it is nanotech for ICT, so nanoscience, nanotechnology to develop new devices for ICT. So that's a pretty focused and unique feature that have the students. So I would say that everybody working in ICT, in nanoelectronics, in nano ICT, let's say, knows this master program. It is running since several years, and as you can see in this very nice picture taken in IBM Almaden in 2015, you can see that there are different students that are of different year of nanotech. So they are students that are doing their PhD there, or they are doing their internship there, or their master thesis there. So being very well recognizing, it is easy for them to make this community of students of different year, and this is a really powerful thing because community is really important today. So about employment, that's another important thing. So do I need a campus certificate in order to enter the course? Okay, C1 is absolutely very good. You normally need B2, but this year you have 1 year. You have time up to June 2021 to take the certification because of this problem of coronavirus. We extended the deadline, so the minimum level is B2. So we're saying about the employment, that is pretty high. So what you see, you can see the Alma Laurea data from Polito and from this course that are about, I think, 90% of employment within the first year. So I mean, really high. And also, what I want to underline here, it is that the idea of the course is to form a high-level electrical engineer that are working basically in the research and development, not in production. So as you can see here, most of the students have a job in research and development. A lot of them are doing PhD, and that's a good point. I mean, PhD, it is an important part. So not just for academia. You see in academia there is just 11%. The probability are pretty small to have a career in academia. But if you want to go in high-tech industries, most of the time, if you want to really go to the highest level, you typically need a PhD. So I mean, it is an option, obviously, but I think in this research and development, high-tech world, it is a good option that you maybe should take into account. There are also others like people that is then moving on MBA, consulting, patent, and things like that. So let me go close to the conclusion. So advantages of nanotech engineer, I think, high interest of high-tech industry, really high. Especially, I mean, from let's say, not just from an Italy point of view, I mean from Europe and US and all the world point of view. There are strong investment both from the industry and from, for example, European action you have seen before. The other thing that is important is, as I was saying before, sustainable numbers of graduate students. I think this is important. So you have few students per year. Let's say we said 60 maximum of the international. Let's say 100, I would say, completely, if you count all of them, not more. And so that means you're recognized, and then this is a really good thing. The other point is I was saying the pervasiveness. So yeah, this is nanotech for ICT, but similar rules to fabricate a very good transistor for a computer work if you want to use the same idea for energy application or environment application or biomedical application. So that's because of the pervasiveness of the nanoscience. So that's why I reported one example of nanotech engineer that is really up to date. So this guy, maybe Liliana I don't know if she remember him. It is Ivan Ferrante that I know very well. He's working in Paris in this company that is called Mobidiag, that is doing diagnostics, mobile diagnostics. So he was a former student of Nanotech, and just, let's say, a few weeks ago, they went out with this new diagnostic system to make the detection of COVID in 15 minutes. So you know how this problem is important, and you know, probably you've heard that normally you need days or even 1 week to have the diagnostic of positive or negative, while in this system you can do it in 15 minutes. So here you can see a typical scheme of a nanotech engineer, because in this system there is biology inside, there is molecular recognition that is on nanoscale, but then there is generation of a signal, there is electronics, obviously, there is wireless communication. So there is all the things that are typical of an engineer, so dominating the whole system, not just a part of it. So I think this is a pretty up-to-date example. So as I was saying, the call for international track is ending. It is already expired for let's say foreign, not Italian degrees. So if you have your degrees that is not coming from Italy, you should have made the apply within the 5th of May. We will have the chance to do practical works in the clear room, sure. Okay, in the international path for sure. As I told you, there is an entire semester in Grenoble where they have very high level clear room that can be used from students. If you do the national path, that will be a little more tricky. I mean, we don't have an entire clear room devoted to students, so you can have you can do some practical labs. Then maybe I will touch also this point if we have time. Yes, for the problem related to COVID emergence. So let me just finish this one. So for people that has an Italian degree, so even if they are obviously not Italian citizen, the deadline is this Sunday, right? So check it on the website. So as I was saying, the language certificate, it is postponed to June 2021, and the short list is given in this way: 70% to your average marks for the bachelor, clean, without any, let's say, subtracting of the worst or the best marks. And then there is a colloquium that will be in mid-June. In this colloquium, it will be more motivational colloquium. We will speak about why you want to do nanotech, what you like in your previous course that make you think about going nano, and things like that. So there is, for next discussion, there will be a chat. So I'm closing this, and then the deadline of this Sunday, it is for the international path for who has an Italian degree. So if you have an Italian degree, or you're going to take an Italian degree at Polito or in another, then you can apply for the international path, the national track, within the next Sunday. You can have a look to this website.